In this fun, yes, fun assessment, we get to experience life as a synthetic chemist where there are multiple ways to do the same thing. And so what's shown on screen are three different syntheses, we'll label them A, B, and C, that are all going to give us the same product. Now I started to just go through this and think about just tell you in words what's happening. I think that would just confuse things. So we'll kind of do a shorthand way of drawing them. So let's start with synthesis A to think about what's going to happen. So we'll label up here that the product of step 1, what will it give? Well, we're using this molecule P2O5. That's going to dehydrate the amide. So the product of step 1 of part A is going to be this nitrile. And I'm just going to keep the R group the same, meaning that basically, if I can point the right way, this whole rest of the molecule is R. When we do step 2, we're going to do actually 2 and 3 together. The process of dibow reduction of a nitrile will give us an aldehyde as our product. Spoiler alert, that better be the product of B and C. Let's see if we end up there. For synthesis B, we start again with compound 1. This is yellow. It's going to be hard to distinguish between yellow and green. But for synthesis B, we're going to start with step 1. We're going to use sulfuric acid, water, and heat. That's going to convert the amide to a carboxylic acid. When we react a carboxylic acid in step 2 with thionyl chloride, we end up with an acid chloride. And then when we use this lithium tritibutoxy aluminum hydride, we said that's a hydride reagent that only delivers one hydride to an acid chloride to make, you guessed it, an aldehyde. So far, so good. We have, in fact, made the same compound. Let's do the last one using a green marker, almost indistinguishable from the yellow, but trust me, it's green. We'll do step synthesis for C. We're going to start this in the same way, sulfuric acid, water, and heat. So the product of step 1 will be the carboxylic acid again. Step 2, we're going to use sulfuric acid and ethanol. This is an alcohol plus a carboxylic acid under acidic conditions. That's the Fischer esterification. So we should end up with the ethyl ester here. And now that two-step process of step 3 and 4, dibow with water, should give us the, what do you think? The aldehyde. So dibow and water gives us the aldehyde again. So the same aldehyde. In fact, let me go ahead and draw it out at least one time fully. The aldehyde we make in this reaction is this. So this is the aldehyde, the product of all 3 syntheses. That was fun, wasn't it? You don't even have to answer, but yeah, that was fun.